Yo, what's up? Huh. Yeah, sorry guys, hold up. The camera's actually broken right now. Not sure what's happening. Uh, Hold up.
I'll Alistair.
Feel the bite of frost.
I really should play with buyback, but at the same time, I kind of just want to buy it. Oh man.
We got the sword. Can we go?
Fuck it. Fuck it, Mason
just
Bros.
looking at
We're
you.
just doing it.
It's going top.
To battle.
This item's so fun. On Troy at least. No one can run away from me.
Break on
We
neck.
went well.
My bow is drawn.
Pretty far, I'm coming.
We should just chill a
My
little bit.
time has
the drop.
come. Your fate is sealed.
I showed the ward.
He's got satanic.
I go in
I have a ward on
silence.
this hill.
Silent as mist.
Oh Jesus, that camp is huge. Fuck.
Good enough.
I have more smokes. I'm gonna give it to Yasuke.
So be
Mid
it.
rush can be up. I think.
But it's not. My accident.
Forward.
that's real.
Way ahead of you.
Alright, I think this should do actually. Oh, fuck it.
Arrow, fly.
Wave bottom is like
Okay.
massive.
Onward.
Yeah, sorry guys. Hopefully I fixed all that and it shouldn't be as laggy anymore. Let me know how things are.
Very well.
Any advice for someone with low GPA right now getting it back up? How important of a factor is it? In the long run, it doesn't really matter that much, I would say. After like 3-5, I would say after like 4 or 5 years, no one really cares, like straight up. The reason why is because at that point, your work experience is really what matters the most. Yeah, so your GPA is only useful for getting that first job. And nowadays I would say that there's like so many people coming out of school with like 3.9 GPAs that at this point it's more about like your own work experience, because you know there's at least back in my day there were a lot of people who were able to get really high GPAs but couldn't teach themselves shit. So that was always a really problematic factor.
I was on me. Okay, good.
Base cigar.
Very well.
This was a really good draw game as long as like I could like
That was
sit
my
back.
thought.
Feeling pretty good, guys. Feeling pretty good.
I got 9K back in 2017.
Enemy's middle barracks have fallen.
Whatever. No one cares.
I'm not ready. My
That's
sentiments
still not
as
the big
well.
event.
Into the
Time
flow.
again.
There are some things you weren't meant to see. My enemies.
Hit him again? Nah. That was a friendly tip,
Tower
wasn't
has
it?
fallen.
Or are
That was
they?
Enemy's middle tower burned to
Me
the
and Lukey are
ground.
great friends. Base cigar.
Feel the frost.
Alright, nice.
Guys, great work. Glad to be a member of the team.
Alright, that was pretty good. New patch. Oh, they already updated it?
Arrow, find your target.
Well, that's my last game. Like I said, I'm really tired, so. But I'll look at the patch on stream, I guess, really quick. I thought I played pretty well. The only game where I thought I played bad, and it was kind of like I played bad, but like there wasn't much for me to do once like I played bad for 5 minutes, was the troll game. It's because like laning should have gone better, and I just got super tilted that he kept denying creeps through his passive instead of actually learning how to play Dota. But it's fine. All right. Learn updates 7. Base armor increase
Hello? Is this working? Let's see. Mm. Hey, I hear you.
Oh, you hear me now?
Yeah.
Okay, I'm not sure what happened there, but yeah. Hey, what's up?
Hey, not much.
Yeah. So yeah, you booked a session with me. Tell me a little bit about yourself. Oh, by the way, say hi to the live stream. By the way.
Hello, everyone. Yeah, so I have a on-site with Google in 3 or 4 weeks. So I'm trying to prep as much as I can for that. Yeah, I've got about 6 years of experience now. Not super good usually at like algorithm type questions. I think I'm pretty good with like data structures, but algorithms are a little bit sketchy for me. So I've been doing a lot of grokking the coding interview, trying to learn everything, and then starting with this, and then over the course of the next few weeks, do like more question-based stuff instead of learning-based stuff to try to practice those. Yeah, so that's kind of like a short intro.
Gotcha. Yeah. So you're mostly at this point focused on execution, not really knowledge base. That's would be fair to say. Yes.
Yeah, yeah. My knowledge base isn't complete, but with what I do know, I just need to practice execution with what I do know.
Got it. Got it. So just to recap, what is missing in your knowledge, just so I have a good understanding.
The biggest thing right now is DP, dynamic programming. Other than that, I'm still going through like heap related stuff, so heaps are a little bit sketchy right now.
Okay.
And then theoretically, I should have like an okay grasp of everything else that's in grokking.
Okay. So heaps are not your. Okay, and then same thing with DP. DP is not either. Okay. So we're gonna work on execution now. Tell me where in your execution do you think you're lacking when you do these problems? Where do you find that you're consistently messing up on?
I think it's definitely in kind of doing the planning and explanation of the planning, because I think especially like in work, what I tend to do is just start programming and then figure it out as I go. I don't really lay out the plan beforehand, which I know is kind of like a no go for like interview type questions. So that's kind of what I have to break the habit of.
Makes sense. Yeah. So basically, what I'm going to help you today is a little bit with that planning stuff. So. Okay, I have an idea of what I want to warm up with you with. So let me pull out the doc. I think I sent you the link earlier, correct?
Yeah, I still need access.
Okay, hold up. So I made it. The link can edit. Okay, so I updated so that you have permission to edit. Hopefully we don't get random people looking at the doc this time. That crap. It shows the URL. Hold up. Let me change the. Okay. 50 webcam. Okay. Stop. So let's do a warm up, and I'm going to time this. Let's put a timer here. There we go. And then let's begin. So let me know if you've seen this problem before.
Okay.
So what I want you to do is find a root to leaf with a specified sum. So for instance, let's say I gave you a tree that looks like this, right? 1, 20, 3, 4, 15, yada, yada, yada. And I asked you to find me a path in that tree starting at the root that would lead me to the sum. So there is a path from 1, 3, 4. That the sum of that is equal to 8. So there is a path there. In the second example, suppose I gave you a path, a sum of 38, right? Well, there are two different paths that you can take. There's a 10 and 28 on the left-hand side, and then 10, 13, and 15 on the right-hand side. And both of these will add up to 38. So this is your problem, and I want you to be able to come up with code that will find every single path.
Okay. So the first thing I'm thinking then is probably DFS, because we want to basically traverse downwards until we find the complete sum that we're looking for.
Mm-hmm.
So that's definitely my first thought is we'll probably go with the DFS type implementation.
Mm-hmm.
The next thing I'm thinking right now is that since we need to find all of the paths, let's try to figure out what we need to pass into our DFS function. So that way we know what we need. So I'm thinking we'll probably need the root, we'll need a sum, and we will need our answers array. So I think that's a good base. We might tweak that a little bit later, but I think we'll start with that. So let's say for example we start at 10 and go to 28, or so we start at 10, and then we add that to the sum, and then we'll kind of recurse through DFS. So we'll say first we'll go left, and then we'll add 28 to the sum, and then we'll do a check saying, let me write this out. So we'll start at root, we'll recurse left, then recurse right, and then in between that we'll say if root is null, we'll just return, and that'll be our base case. And then in there between we'll say sum plus equals root dot value, and that will kind of be when we get to that node we want to add it to the sum. And then if we have actually, okay, so what we'll have to do then also, here's a question. Are we going to return an array of the numbers or an array of the roots? Or
By an array
nodes.
of the roots. What do you mean?
The nodes, I mean.
So yeah, what do you think is the most reasonable way of returning this? What do you think the most appropriate output is?
I would say probably the nodes, because the numbers themselves are just really telling us it exists, but the nodes themselves are kind of like the container of information we're looking for, if that makes sense.
Okay. Then let's do the nodes.
Okay. Then we will do results. I'm going to be using JavaScript, by the way, if that's okay.
That's fine. I don't care.
Okay, so we want to push the root, or the current node is just called root in this scenario.
Mm-hmm.
Yeah, so let's see. We come in, we have 10, we push 10 into the, or I guess I called it answers, answer.push. And so now we have 10 in there. Sum is also equal to 10. We'll recurse left, going to 28. So we'll come in 28, we'll push 28 into the array. And then sum will be equal to 38. And so this is where we'll have to do the check right here. Something like if sum is equal to target sum, yeah, so this is already where we'll have to add some more parameters here. So we'll need a target sum because we want to make sure we have that at all levels while we're doing our check. And then we'll also need the, hold on, so answer, yeah, and then we'll need like a results array because we need to track what our current array looks like with the answer array, but we also need to track the overall results that we're going to return back with the results array. So then we'll do results dot push the answer array.
Okay.
Yeah, so that's our left side down, because then when we go to the left and right of 28, they'll be null, so those will just return out. So then we'll recurse into the right. So when we come back up, we'll have sum is equal to 10. Our answer array just has 10 in it again. And then, you know, there might be some weird stuff with like JavaScript and how it does arrays and passing through memory, so we might have to play around with that a little bit, but we'll come to that in a little bit later.
Okay.
So we'll go to the right. 10 goes to 13, so we add 13 to our answer array, and our sum is now 23. And let's see, what was the target? 38. All right. And then we'll go left to 14, which will make 37. And then, all right, this next node is going to cause me to add something to this design. So we're going to recurse left again, going to 21. And that's going to add 21 to the array. And now sum is equal to 58. So at this point, I want to say if sum is greater than target sum, just return, because there's no point in continuing down the tree at this stage, because we know as we add more, we're not going to go back to. Sorry, actually, are we going to have negative numbers at all?
You might.
Okay, then.
Look at the examples. The example I gave you didn't specify whether or not the binary tree was ordered or not. It's just 2 nodes. I didn't give you any restrictions on that yet.
Okay, then if we can have negative numbers, I'm not going to add this check, because we could get back down to the answer. So that'll recurse through the 2 nodes below, 21, 22. Neither of them is going to return the result we need, so we're going to go back up to 13 and recurse down the right side now. So let's see, that goes back to 23. So now we go to 15. And that'll go up to 38, and we'll push this into the results. So I wasn't keeping track. I wasn't keeping track of the first results, so we'll just results equals an array of arrays, and the first one was a 10, 28, and then this one is going to be that one. Yeah, so that'll look something like that. And then, all right, so that was 15. And then it'll go and recurse down left and right on that, and it won't find that either of those add up to the result. So it'll just return out of the entire stack, recurse stack at that point. So I'm feeling pretty confident with this design, and I think this is the right way to continue forward if you're good with that.
Do you see any potential bugs?
Potential bugs, you said?
Are there any situations I might throw you in that may cause any issues?
Let's see. So I didn't add that, so negative numbers should be covered. Let's see. Let's get rid of these so I can look at this. So we have root. If the root itself is null, that's fine. Actually, no, we want to push that. All right. Sum. Push through the sum to all the other nodes down the line. Sum is equal to target sum. Push the results. Or push the answer to the results. Nothing's jumping out at me immediately.
Do you want me to give you another minute with it, or do you want me to tell you?
Let me write out my own tree example and see if I come up with it.
Okay.
Let's see. So it doesn't have to be balanced. We established that. So let's start with something like let's just start with a 0.
I'm gonna tell you, it's a very simple mistake.
A very simple mistake.
Very simple.
Those are always the ones that get you.
And don't worry, I have plenty to yell at you about after this.
I'm sure as soon as you say it, I'll be like, oh my god, how did I not see it?
Yeah. Okay, by the way, chat, type in your answer if you know what he's missing.
Okay, let's give chat a minute and then.
No, you need. Don't worry about the chat. Worry about you.
Okay. I was gonna say when they get the
Only
get
when
their
you give
guesses in.
up. Only when they give up, then I'm gonna let chat rail on your ass.
Okay. Very simple mistake. I think when I get to the end of the recursion left and right, I need to pop out the current number from the answer array.
Yeah. Really simple mistake, right?
Yeah. Yeah, I think in my head I was thinking it might just like automatically come out of the array because we're like going back up, but that's definitely not right. So yeah, we need to pop out the answer after we're done recursing. So that way when we're going back up the tree, we're not getting those numbers left over in the array, basically, right? So
Okay. So then, I mean, yeah, this looks mostly right. Why don't you write it out?
sure. So we'll just do function DFS, and we'll take in a root, sum, target sum, answers and results. Or no, we'll call this like a cur answer for current answer. All right, and then let's see. So first off, if root is null, actually we'll just do that. So in JavaScript you can just do like a double not there and it'll basically cast it doable. So if it's like null
Sure.
or undefined,
Sure.
we'll just return from that. And then we can say cur answer dot push the root, which is the current node. Then sum plus equal the root dot value. Then we'll say if sum is equal to target sum, we'll do results dot push answer, and then we'll do DFS on the left and the right, and then we'll do answer dot pop. All right, so that's pretty much the code as it is. Let's run through it and make sure nothing got lost in translation. So I'm just going to copy this tree that we ran through earlier down here. So let's keep track of everything down here. We'll say root equals sum equals target sum equals and then results equals. Okay.
Okay.
So we come in from 10, which is the root. So we start there. It is not null, so we don't go in through there. We push the node itself to current answer, so just we'll use 10 for that. And then we add the value of the root to the sum, so that's 10. It is not equal to our target sum, which in this case is 38. So we don't push our current array to the results, and then we recurse down into the left node. So we come back up. Left node is not null, so we don't go in there. We push 28 into current answer. And then that goes into the sum as well. And that is equal to the target sum, so we will push our current answer array into the results array. Now we're on 28, we look left, we look right through these two, and we don't see that. We see there's no nodes, it's null, so that doesn't do anything. And then we pop 28 out of the current answer array. Sorry, I didn't update this function or variable name. Yeah, so we're back up at 10. We looked left, now we're looking right. So we come down, we're at 13. Oh, sorry, when we came back up, sum would have also gone back to 10. Yeah, okay, so we go down right, we look at 13. We add 13 to the current answer array. We add it to the sum. And then it's not equal to the target sum, so we look left, 14. Which goes to 37, and then we look left, and that's not equal to target sum, so we don't do anything. And then we look left, and that's going to be 21, which puts that at 58. 21 goes there, and that is not equal to target sum, so that's not going to do anything, and we'll look left and right from there, and those are null. So we'll pop out 21, go back to 14, look right. I'm not going to write it all out because it's going to be the same thing, just with 22 instead of 21. So we'll go back up to 14 after that runs through.
Yeah, you don't need to continue. I already got the gist of it. I think you were already convinced yourself as well. I think we're both convinced of the efficacy. Now, you did mention that there's a pass by reference versus pass by value here in this line, right? So how does this change? How would you change it if it's pass? Because right now you're assuming it's pass by value. How does it change if it's pass by reference?
Yeah, so let me think about this. So if we push the answer to the results, when answer gets copied, or when answer gets modified, okay, so what we need to do is we need to slice this, and in JavaScript that creates a deep copy basically, so that way when we modify answer, this is current answer technically.
Mm-hmm.
So when the current value gets popped out, it won't modify the array that's in the results.
Okay.
So
all right.
slicing will solve that issue.
All right, time space complexity?
It'll be O of n. It has to go to every node at least once for the time.
Mm-hmm.
For space, it will also be O of n, because we could have basically every node gets it pushed into an array.
Are
That
you
could be a
sure?
result.
Try again.
Let's see. Well, let's see. So if we have those two, so I mean, it will never be. There's only one way it could ever be one node, and that's if the tree itself is one node.
What is the maximum length of any answer that you can give?
The maximum length is O of n. Or no, sorry, it's O of log n.
Why?
Because you can only ever have basically like one path through the tree as your result. So like the answer that you're pushing, like for example, if 10, 13, 15, 24 added up to the target, all these other numbers wouldn't be possible for them to be in the answer array. So any one single result will be log n.
Correct. So basically, you can assume that it's a log n solution. Because I mean, you could always say, "Oh yeah, well, worst case scenario, you run through every single node, and store all the answers in the results." I mean, you could also argue not to really count the results because these are just like us emitting them. We could have easily just print them out. But yeah, the track I think I wanted you to get on was the log n one, so that's fine.
Okay.
So basically, it took you about 19 minutes to do the problem. Few help here and there, but basically, you have this problem that I call the expert beginner, why do I call it this? It means that you're definitely beyond people who don't know what they're doing. You've demonstrated that you have practiced. But that's it. You've demonstrated that you've practiced. So what do I mean by this? What I mean by this is that you set up yourself with a skeleton, right? Up here. Of the DFS. So you essentially, I thought you were going to start writing code, but like, okay, it's fine. It's relatively simple. I don't really care. But what I didn't like was that you just went ahead and said DFS and then just started writing your pseudocode without ever explaining to me what you're doing start to finish in English sentences. So in other words, I'm basically just kind of following along and you're just kind of rushing on ahead, which is going to lead into some problems. I'm going to explain that later. But for now, it was, if you remember, you were basically like on this answer push, and then just like while you were testing your own code, you were writing while testing essentially. It's like, oh, I ran into this situation, let me patch it. Oh, I ran into this situation, let me patch it. That sort of thing. And while the code is relatively simple and then you're not likely to come into any mistakes, the real penalty was when you had to try and figure out this last mistake. Do you remember this at around like 11 minutes?
Yeah.
Yeah. So basically, out of the 20 minutes that you spent, 3 to 4 of them were literally just trying to write down answer.pop. Now, what you told me was that, hey, in my mind, I just assumed that was going to be there. You remember this?
Yeah. I for some reason in my head I thought like, oh, when we come back up through the stack, that will just like automatically modify the array, but that's wrong.
Yeah. So, but that's what I mean. It's because you're keeping too many things in your head. You're trying to create the code while testing your design, and at the same time, it's just like you're so focused on that, you miss this little detail. And of course, that's going to ding you on a lot of places. Now, if you had already said in the beginning, oh yeah, if you went through it step by step, saying, hey, I'm going to push this stack, I'm going to add, I'm going to recurse to the left, to the right, and then I'm going to pop out. If you had said that at the very beginning, I could have easily reminded you, oh, you said this one thing. What was it? And, you would have easily reminded yourself. But the fact of the matter is, I have no justification to give you that hint. So, in other words, I do not know if it's because you misunderstood what a stack is supposed to do or what is going on through your mind. I cannot give you that hint. So I can't remind you of anything that you had just said. Therefore, my hands are tied as an interviewer. I know what the answer is, and I know you know what the answer is, but I can't write down, hey, this guy just made a small careless mistake that he already knew about. I can't write that because you've not shown that to me. Does that make sense?
Yeah, and then this is kind of what I was describing at the beginning, is that like the way I would code in like a day-to-day scenario like is I would just forget to do that, and then I would run through the code like in a test case and then see it breaks because I forgot to pop, and then I would put the pop in. So that's kind of like what I was describing exactly as the issue that appeared.
Bad habits are showing up. I mean, like that kind of like, I expect that from an L3 engineer for sure. L4, I would be like, I would expect you at least, if you're going to make that mistake, at least do some planning. That's at least what I would have wanted. Now, you also did stop and realize, hey, wait a minute, what if we had negative numbers? That goes more along with, oh, yeah, well, I'm going to code, and then I'm going to figure out my issues later. Now, obviously, not everyone can figure out. We're always going to run into some random issue later on down the road that's unforeseen. That's fine. But you made no attempt at trying to figure out the premises of the problem. I mean, you kind of did the whole thing, but then you stopped to realize, oh, well, I might have negative numbers. Is that possible? While you were designing, like while you're writing the pseudocode and running through it. Now, if you're just planning, then it's like, okay, I understand. But the fact that you are planning and running through it is like, it's a weird feeling for me, and I could have drifted either way. I could have said, oh, this guy's just planning, let me just like clarify that for him. Or he's like, oh, he's actually writing it, well, he already has a plan in mind. Those are two different scenarios in my mind. So if I know you're planning, and I distinctly know you're planning, and you're asking the question as if you're planning, then I can be more forgiving. So it's like all these little things that just show up because you have this one habit of writing it shit out. Does that make sense?
Yeah.
So, and it's like another one, it's like, oh, well, what happens if this tree is, ordered or not? Well, I never said it was ordered. In fact, the examples that I gave you were specifically not ordered. So that is also an issue. So again, you just make all these assumptions and you go, and you need to do some planning ahead of time. So, essentially what it boiled down to was you losing about 20 to 25% of your time was easily avoided. Like, mistakes caused 20 to 25%. It costs 20 to 25% of time to be wasted. That's essentially it. You could have just boiled down your 20-minute problem to 16 minutes just off of that alone.
Right.
And then you have like small few mistakes. In fact, let me just write down the. Let me just copy paste my notes. So I should put in the timestamps for you guys. But yeah, it's like you jumped on DFS. Why did you pick DFS? Why did you throw it at it? I mean, of course it looks obvious like it's a DFS. But it's like when you say DFS, I don't know if you mean in order, pre-order, or post-order traversal. And so I'm like, okay, well, it's either you have made some assumptions again, or you are misapplying it. It's one or the other. And you never really built up to that discussion here. You're testing while writing, patching on code and parameters, kind of, again, similar situation, acknowledging the memory limitations. I thought this was good. I think this is good in the sense that you are aware of what can go wrong, but bad in the sense that you don't understand how your own language works.
Yeah, I mean, yeah. I guess part of that is it's my own folly for going with JavaScript when I'm not a JavaScript expert. I admittedly only go with JavaScript because it is easier to manipulate arrays in JavaScript than it is C#, which is what I know really well.
Working with what you know really well, dude. I use freaking
just
Java for my interviews, and that's like the worst language to do.
Yeah, I guess part of it is grokking doesn't have C#, so I've been practicing JavaScript for that anyway.
Mm-hmm. Yeah. So I mean, that part I can't really help you on. It's pick a language, get good at it. That's all I can really say.
Yeah.
But what I think is really important that I think other people should take away on stream is the fact that you are doing the stack trace. I want to at least commend you for that. I don't want to be completely harsh. I like that that you're able to actually walk through your own answer, say what the value of the variables are, and then go through it. I like this a lot because it shows me, hey, at least you know what you're supposed to be looking out for and what can get you. But it's just that this is just a makeup on a pig, This is really meant to help prevent you from getting in that situation to begin with, but it does help to double check things on pencil and paper,
Yeah.
So.
If I could give your audience a 10-second soapbox, is learn how to use a debugger and breakpoints. They don't teach you that in school, and it helps you a lot when you're trying to learn algorithms.
Sure. Yeah. So here, does everything I've said so far make sense, and do you agree or not?
Yeah. So, this is kind of, so you wrote like writing code. Why writing code ? That's definitely like one of the biggest things I noticed in my practice as well. Like, I don't write it in plain English. I kind of just like write pseudocode, almost code. It's like missing like one character to be real code, basically.
Mm-hmm.
So yeah, that's definitely like you're making note of like what I thought was my biggest problem. So that basically reinforces my thought there.
Mm-hmm.
Yeah, and then like you said, patching like the code and parameters. I think what I need to there is like, again, come up with like more test cases than what you give me in my head, or not in my head, on paper. So that way I can kind of plan out those edge cases, for example, before we get to like line 5 of the code, and I'm like, is it going to do this or this? Yeah.
Okay.
Yeah, I think I agree pretty thoroughly.
Okay, so what I want you to focus on, I'm going to give you another problem. This one's going to be a little bit harder, but you really need to design very well for this one. So
okay, and then I guess one last note I'll say about the problem is when you pasted it in, I was like, oh shit, I don't remember anything anymore. And then like very slowly I was like, oh, DFS, right? Okay, and then I think I just got so excited that I was like, yeah, DFS, and I'm like, let's go.
Yeah, I mean, that happens, but then it's like you just have to be very analytic, step by step by it. It doesn't matter how long it takes you to do things step by step, but that's almost always the safest way of doing things, and your interviewer will appreciate the logic. So, all right, here's another problem. I'm not going to time you on this one. I'm going to, since I have a very good understanding of where your skill level is at, I basically picked this problem because it's a little bit more complicated and that you have to spend more time understanding it. But this is going to be a much more interesting problem, I think. So.
Okay. Yeah, and I did agree with your assessment of like the experienced beginner, because like it's obvious I have programming experience, but I'm like very beginner in like doing these problems the correct way, basically.
Okay, so this is going to be a lot more complicated. It's a graph problem, but follow me on this. So suppose I have a directed build graph, like a directed acyclic graph of every single module in our code base. The module represents so we have two different types of dependencies, a dependency and an exporter dependency. A dependency just means that one module cannot be built without relying on the other. So for instance, let's say I have module A and it has a dependency node B, right? Module B. For instance, let's say a class in A imports a class in B. A cannot be built without node B. So if I don't have that dependency, then A cannot be built. My graph will fail. Follow me so far?
Okay, so a dependency cannot be built without relying on the other. Node A has dependency on B. For example, A imports B. A cannot be built without B, and this is an error case. Okay, so if B is not listed as a dependency on A, there will be a build failure.
Right. So if this relationship does not exist, then A will fail to build. B will build just fine because it doesn't care what's downstream, right? But A is the thing that depends on B, and if we don't have it, then A will fail. Does this make sense?
Hold on. So you wrote the arrow going from B to A. I wasn't picturing it in my head A to B though, because basically A won't be able to build without that dependency listed, but B could build without it. So what I was thinking was more that if you put it this way, then it's kind of like if you build B on its own, it's just kind of hanging out here. But if you build A, you have to check that B is there.
Okay, I see. It depends on how you want to define source and sink. Personally, I just do it the other way because I can see what's downstream, and you're thinking upstream. It doesn't really matter. It's however notation you really want to express this as. So there's another kind of dependency that we have. It's called an exported dependency. An exported dependency is a dependency where if a node is a dependency, then all its own exported dependencies are also exposed and counted. So for instance, let's say I have A has node B as a dependency, right? First example that we have. B lists node C as an exported dependency. So B is dependent on C, but in another way. Therefore, A has information to node C. So for instance, class A can import class C. Now, because of this relationship, right? Does this make sense?
Yeah. I'm picturing like NuGet packages in like C# where basically if package B has a dependency on C, package A gets the same dependency to C, but it's implicit basically.
Sure, it's an implicit. That's another way of putting it. So the moment I turn this into just a normal dependency, this will fail because A requires something from C. So, and I want to also clarify that you can also have a very similar relationship if you just did this as well. Right? Does it make sense?
Okay, that part makes sense. Where you lost me was if you change this from an exported dependency into a normal dependency, then A breaks. So what you're saying is if it's an exported dependency, it travels upstream, but if it is a direct dependency to B, it does not travel upstream?
It doesn't travel. So, for instance, it's transitive. Exported just means it's transitive.
Okay.
So, now let's suppose that our build graph is very dirty, and we have a lot of node relationships that are improperly defined. So the first step I want you to do is create an algorithm where there are no unnecessary dependencies. And you can assume that you have these three functions available to your disposal.
Okay, we have a dirty graph, a lot of node relationships that are improperly defined, no necessary dependencies that is error-free, and assume you have access to these static functions. So we have does valid relationship exist, where it takes a node and a dependency, or a target node and a dependency node. So that's something like you'll give it the target and then dependency and then return. Okay.
Right. So like let's say if I gave you A comma C, right, as the parameters, and then I had this situation A import C, then this would return true.
Right.
But if I don't, it's like if I don't have that, then it will return false.
So if we take the example from earlier where we have A is relying on B with the exported C, will that return true or false in this case?
Well, what are you passing in?
A and C.
If I'm passing in A and C, then it depends because these are referring to the classes themselves. So I might be able to expose A and C, but like let's say I have that relationship, but I don't have A import C at all. Let's say that this does not exist. So then this will return false. So this is a valid relationship based on the classes that exist within the modules. Does that make sense?
Okay, so it is only checking like the direct dependencies, not the export dependencies. Is what I'm hearing.
No,
there.
it checks the export. Like I said, if I pass in A and C, and I do not, and I have this relationship, right? If I have this relationship, then it will be true. If I don't have that relationship, if I don't have any file in my A that imports C, then it's going to be false.
Okay, I see. So like, you can have this A relies on B with exported C, and technically C is like there, but if you don't utilize it, it doesn't return true.
Right.
Okay.
So what I want you to do is make sure that there are no unnecessary dependencies.
Okay. Okay, so that explains that, and then we have collection node graph. What does graph, the function graph do? Is
It's
that just like the?
It's just the actual
wrapper?
graph itself.
Okay, that's just like the wrapping function.
Yeah.
Okay. And then remove dependency relationship. Okay, and then this is just what we pass in the two nodes to break the dependency on if we don't need it.
Mhm.
Okay, so the very first thing I'm thinking is, how do I word it? How can we tell if A uses a class from the exported C library? So, does it look exactly like this, or will, because like, so C in this case is exported. Is this a case where C is not being used at all in A? And if it is used in A, then we'll have something like A, B, C. So
What do you mean?
So like if A does end up using something from C, sorry, it wouldn't be like that. It would be like A, B, and A, C.
Okay.
So for example, A doesn't use any class from C. In that case, A uses class from C. So is that what determines if that exported package is being utilized by the upstream package? Is if it looks like this versus this?
No, not necessarily, because again, you might still have this relationship. So for instance, this would still work, right? If I made C an exported dependency here, then A has visibility into C, correct?
Yes.
So, and if I have class foo imports class C, then it will be then this function will return true. But the moment you do this, well then yeah, this will still exist, but then you might have broken B. Do you understand why?
Yeah, because B has a dependency on C.
Right. Exported just means that it's transitive and available to everything downstream if you import this B.
Yeah, I guess in this exact scenario, I'm just trying to figure out how a downstream, or upstream in this case, package might be using C.
Okay. Just think of it like importing a class in a Java file.
Yeah. Okay. That's not 100% clear at the moment, but maybe it'll be clear once we start planning this out a little bit more.
Okay.
So I'm trying to think of even where to start with this.
Mm-hmm.
Okay, so first we need to start with the root node, right?
Okay.
So we're gonna have a root, and under the root, root will have like a list of dependencies, right?
Okay.
So that list of dependencies is basically going to be other nodes in the tree, or the graph rather. So let's say, for example, we have like A, which will rely on 3 packages. So like B, C, D, and then we could have like B, which relies on E.
Okay.
And then, you know what, let's also make D reliant on F.
Mhm.
But we'll make that one exported.
Okay. Let's do. I would suggest doing like a double, just as an annotation.
Yeah, that makes sense.
Sure.
Okay, so we'll use this as like our test case for our planning purposes. So we have A, we have the list of dependencies, which is going to be BCD, and then basically we're going to need to check all of the okay, so hold on. This is like an actual good graph. We need to be checking for a bad graph. So we'd also need to be checking like A also has like a dependency on E, for example, directly. And then that would be like a bad graph in this case.
Yeah, as long as A doesn't import, like class A doesn't import class E. Because why am I importing E if I don't use it? Does that make sense?
Yeah, I guess the part I'm getting hung up with that part of the description is how do we know if A is using E or not? Because I guess in my head what I'm picturing is like a project's file structure, and then like classes.
That's what this
inside that.
function is for. Does there a valid relationship exist? You remember what I said? If I pass an A and C into that, then I'm checking if class A imports class C.
Oh, okay. I understand now. I was thinking, does valid relationship exist? Was doing something completely different. I understand it now. Basically, it's saying, it's not checking two nodes to see if it's valid. It's saying, is there a relationship?
Okay,
If
yeah,
that
does
makes
a relationship exist?
Yeah. Okay, because what I was picturing in my head was like, never mind. It doesn't matter. I understand it now.
Okay.
So we can do something like, so we're gonna have to like for loop all the nodes in the dependency list for the given node. Okay, so that's the start of it. Now what we're gonna have to do is when that ends, basically we're gonna have to check the nodes that we've already visited against. So okay, I guess I'll tell, this is separate from the interview question. I'm just going to mention I haven't done any graph questions yet, and I'm picturing something like a Dijkstra's algorithm, or not Dijkstra's, but like some graph algorithm that I don't know, but I think I need to know for this. Do I need to know a graph algorithm for this?
Dijkstra's algorithm only is applicable for weighted graphs, right? This is unweighted.
Yeah.
There's not really any special trick to this. I mean, there is one, but it's not really that interesting. I mean, if you just remember what a basic... I mean, I don't want to say what it is, but it's like you don't need any fancy algorithm for this.
Okay, then what I'm picturing in my head is we need to do some sort of like BFS based algorithm then, because what we want to do is we want to check all of the direct links to A before we go any deeper.
Okay.
So basically we'll do like a BFS in there. So, or sorry, not BFS in there. BFS, and then inside the BFS function we'll have like a, there's no for loop. Just a BFS function. Okay. Maybe there's a for loop. I'll figure that out in a second. So we have A, and we want to first check B. So we'll just say like BFS, like, okay, there is a for loop because we need every node.
Okay.
For all nodes in A depths. And then BFS node I just being like the iterator. So that'll go to B first. And then when we're in, so I'm gonna write like a BFS function down here. This will be what's in the BFS function. We're gonna need to check if a valid relationship exists between the two that we're checking. So in this case, A and B. So we'll have to pass in the current node and the target node. But we already knew that. But so something like that.
Okay. I want you to keep in mind that you still haven't told me exactly what you're planning with BFS. All you've told me is, hey, maybe there's something we can do with BFS, but now you're starting to write code. Again, remember what we said. I want you to focus on design, and I'm going to be really harsh on you on this time. What the heck are you going to do with BFS?
Yeah, I guess part of the problem is I don't have like a complete idea, and I'm trying to figure it out.
So, okay, so you write out English sentences, but I do not want you to write code. If I see you write code, I'm going to yell at you, okay?
Okay.
So.
And I have to figure out what I'm gonna write. Cause,
Yeah. Communicate like I'm a 5-year-old child. Well, a 5-year-old child wouldn't really understand build graphs, but you get the idea.
He might faster than I do. Let's see. So, for every node in the A dependency, no, I'm not gonna write that. I'm gonna write like BFS here. And
Okay.
then we'll just assume that we're going to do a BFS for each of these nodes. So we want to check if the dep from current node to dep node is valid.
Mm-hmm.
And then we want to also say hold on, we're gonna have to do like, if it's BFS, we need like a queue of some sort to manage the different layers. Okay, this is where my algorithm knowledge is failing me because I'm trying to figure out now. This is something that should definitely like be already in my head and not me trying to figure it out during an interview. Is like how BFS works.
Okay. If you want, we can pull the plug on it, because if you don't feel like it's going to help you, then there's no point in continuing.
I can definitely do like the first layer of dependencies, but like recursing down to like E and F here, I'm gonna have to like figure it out, and I think that's like a bad thing to be. That's already like I've already failed at that point.
Yeah. I would say if you don't have a good understanding of graphs, then you should at least go back and do it, because there's no way you're going to do this problem without actually understanding what graphs entail.
Yeah, I mean, I understand graphs to the point of what they look like and not so much how to work with them.
Okay.
So yeah, I think we're going down a failing road at this point, I think.
Okay. So what I'm going to say to you is that the key to solving this problem was a topological sort. Do you know what topological sort is?
That's like my next section on grokking.
Okay. So basically, you already understand. So to give you a quick preview, topological sort just means sorting them by number of vertices that are going into them. So number of dependencies that they have. So for instance, we would be visiting E, F, because these have zero arrows going into them because they don't depend on anything. And then we would E, F, C, or in whatever order. Then B and D, then A, right? Excluding E. Does that make sense?
Yeah, so basically you'd have to have like a stack of some sort, right? Because you want to
Q, really.
or Q. Okay. I guess I was thinking like because you want to get to the bottom and you want the bottom on the top.
I mean, yeah. I mean, you could do it as a stack too. Although I think I'm most familiar with it as a queue. Either way, if you hadn't mentioned that, then I think the whole situation becomes so much easier. I'll let you chew on why, but for now, at least we've exposed this part, because you did say heaps and dynamic programming before. Now it's like, now I know that there's a graph problem that I can't give you. That's fine. So at least we understand this, but hopefully you understand that at the very least you need to spend a lot of time to really understand a problem before you even write the code for it.
Yeah, so I mean, I guess I was, as soon as I had wrote that one, like, does valid relationship exist, I even thought in my head, like, oh, he's not going to be happy that I just wrote that line. And then you weren't, and I was like,
Nope.
yep.
It's fine. It's Pavlov right now. As long as I can get you to say, hey, wait a minute, maybe I shouldn't be doing this. If I can get that in your head, then I've already done my job as a coach.
All right,
So-
well, we're at that point, apparently, because
Yeah.
that's exactly what I thought, and it came true.
Perfect. So we're gonna I'll give you another problem, but at least we're making some progress, and and we know that your graphs are gonna be a weakness. So let's at least take a look at this, and why topological sort might be the answer for people in the live stream who have figured it out. Yes, you are going to topologically sort it, and you are going to essentially just check for every single dependency. For every single target, you check a look at their dependencies, and then you look at the transitive dependencies. And if those transitive dependencies exist, then it's fine. But if they do not, or the relationship is not valid, then you go ahead and remove it. But it has to be for every single transitive dependency in that dependency. I know it's a lot, break it down, but I'll give you the answer next time I give this problem. So, this is a problem I like to give. It's one that is very, very hard for people who do not understand how to plan out properly to actually solve. Because, it requires you to actually fully understand what I'm talking about and the graphs. So, another problem.
Yeah, I'd be interested to know how I would do if I did know what topological sort was going into that.
It's relatively simple, actually. It's astoundingly simple once you have the basic idea. And that's kind of the whole point. So, all right, another problem.
Okay.
So let's suppose I gave you an array of a bunch of zeros, right? Well, let me just turn off something here. Okay, so I gave you a bunch of zeros, and I gave you a target array of the same length. I want you to return the minimum number of range increment operations needed to arrive at the target array. So, for instance, let's say I have a starting array of all zeros, and then I give you some random target array at the end. I need to know how many range increments I need to perform. Oh, wait, did I give you the answer? Fuck.
Oh, I didn't read down there. so
Okay,
you're good.
okay. Yeah, so anyone who saw the answer, forget that. Anyway, so suppose I gave you a bunch of zeros, and then I gave you some target array, right? I need to know the number of range increments that is going to take in order for me to transform that starting array into the target array. Does that make sense?
So, what does range increment do? Oh, it increments everything within a range. Okay, I see with that line. Yeah.
Correct.
Okay, so let's see. Let's write out some. I lost formatting.
That's fine.
Let's see. I want Arial and not background. And then black text. Nope. Okay, we're back. Yep, good. Okay. So all right, so let's see. We have starting array. Let's start with something a little more smaller, just to kind of work up a starting example to kind of get an idea of what's gonna need to happen here.
Mm-hmm.
So we have a starting target of 1, 2, 3, and a starting array of 3 zeros. So basically, what's going to happen is we're going to want to call range increment from 0 to 2, right? Because we want the entire array at this point. And that'll give us 1, 1, 1.
Mm-hmm.
And then we want to do range increment on 1 to 2, and that'll give us 1, 2, 2, and then the same for the last one. So that's so understanding what we need to do with this at least is pretty straightforward. So now what we need to figure out is how do we determine the range that we want to increment, because we want to basically, like in this example given, we only want to increment the second index one time. So like for example, even though the numbers around it need to be incremented multiple times, we won't be able to do like 0 to 4 up until 9 times, because then everything else will be overflowing their target. And there's no like decrement, right? So there's no decrement in this question?
Nope, only increment range.
Yeah. Okay. So what we need to do then is figure out a valid range to increment without sending any numbers over their target.
Mm-hmm.
So, we lost formatting. This is weird.
It's
but,
fine. Don't worry about it.
Okay. So, for example, if we look at the full array of the target array, so full target array,
Mm-hmm.
include any okay, so we'll say like pass in an empty array for the indexes. So
Mhm.
basically what we're going to do is we're going to look at each index in the target array,
Mhm.
and then if that number plus 1, or even we can just say like if the number is equal to the target number,
Okay.
then we won't include it in the empty array of indexes that we're passing back.
Okay. So what do you intend on doing? You say you're gonna pass in. You have an empty array of indexes, and look at a full target array. Include what? What do you plan on doing with this?
Yeah, so basically when we look at the target array,
Mhm.
we'll say look at the full target array, include any number or any index of a number not equal to its target.
What do you mean
Uh,
target? We'll specify
sorry.
target.
So yeah, so we're gonna have the starting array here.
Mhm.
So again, we'll just take the simple example, so we're not writing out a bunch of numbers.
Sure.
And then we'll do 1, 2, 3.
Okay.
So when all of these are 0, 0, 0,
Mhm.
and we compare the two arrays, we see that none of the three numbers here
Mm-hmm.
are at their target. So like,
Oh, like their desired number.
yeah, so like
Okay.
we'll say like starting array 1 or starting array 0 is equal to 0.
Okay.
Does that equal starting array, or does that equal target array 0? And we'll say no. And then so we'll have like this another array here of indexes, and we'll push in 0 because those aren't equal.
Mhm.
Right? So then like when we do increment these all by 1, we'll say, all right, so the zeroth number is equal,
Okay.
but 1 and 2 aren't. So then we'll push 1 and 2 in. And so that's the first part of the problem, is figuring out which indexes we do need to increment.
Okay. Keep in mind though that I may also have like a situation where you have come up with a happy case where everything is incrementing, right? What happens if I come up with a 0, 1, and then 0 again?
Yep. So that's the next part of
Yeah.
what we need to figure out.
Yep.
Because basically you can have like indexes 1, 2, 4, 6, 7, right?
Mm-hmm.
And so you don't have like a contiguous number range. So the next part of it is we need to figure out, okay, how far can we advance through our indexes until we find one that's not like the number plus 1, because then that'll determine the range that we can increment. So
Okay.
we'll have to do, like in this example, we'll have to do 3 increments. We'd have to do 1, 2, 4,
Okay.
6, 7.
Okay.
So basically,
Okay.
we'll have to say in the indexes array, traverse through until the next number is not the last number plus 1.
What do you mean the last number plus 1?
So like when we get to 4,
Uh-huh.
the last number being 2 plus 1 is not equal to 4.
Okay.
So that way we know, all right, basically we need to take everything from the number prior to the one we're at to whatever we were at before. So we'll have to store like the beginning of the range, and then
Okay.
when we find the end of the range, then we can do the increment.
Okay, but then you might end up in a very ugly scenario where you have 1, 5, 7, 9, and none of these are plus 1. So How do you plan on handling this?
Yeah, so what I was thinking when the question first popped up is, can we sort and unsort in some way?
What good does sorting help you do? Because I still have a target. This is a final state I want things in. How does sorting help you?
Yeah, so sorting helps because you can then do greater ranges of increments. But the problem then becomes, how do you unsort? So it's kind of like we'd have to store like the original order of the array somewhere else, and then do all the incrementing that we need to do to the sorted target array. So like the starting array and the target array will be sorted, and the starting array can then go like, here, you know what, let me copy this example.
Yeah, because well, here's the thing. Like, it won't work either way because your increment range is determined by the order as well, like what it affects. So if you decide to increment range from, like, let's say 1 to 4, and then you rearrange everything, well, then your 1 to 4 operation was not valid anyway.
So the sort would only happen once in the beginning, and then we'd have to like unsort it is the thing.
Okay, but again, you do not have access to that unless you have some way of doing it efficiently that I don't know about, but I'm going to say don't go that route.
Okay. Yeah, I feel like that works, but it's very, very complicated and probably not very time efficient. So let's not go that route.
Nope.
Okay, what was I thinking before then? Okay, so we had just determined that we would traverse through until the last number is not, or the current number is not the last number plus 1. So, but then you raised the point, what if we have like 1, 5, 7, 9, where none of them can be chunked together, right? So the problem at that point becomes, well, we're going to have to increment them all individually, and that is not great, but I'm not sure how can we get around that. So we have 1, 2, 3, 1, 2, 1, and we're at 1, 1, 1, 1, 1. We have to do 1, 2, 4. But that, I mean, that could be like, let's change that to a 3, change that to a 1, 1, 4, and then that'll be 1, 2, 0, 1, 2, 0, 1, 2, 3, 4, 5, 5, 1 through 5. Yeah, I don't know how we can get around, like, if we have a case like this, just we'd have to increment those individual indexes by 1 every time.
Okay.
Individually, I mean. I don't really see a way around it if we can't do any sort of sorting, because then we can't really chunk them together if they're not sorted.
Well, keep in mind, what exactly are you trying to solve, right? You're trying to return the minimum number of range increment operations that you need.
Right.
So let's actually take this example. Let's suppose that you started. Let's take like this very, very simple example, right? What is the minimum number? What's the minimum order that you? What's the minimum number of increment operations that you need?
Let's see. 1. Do you want me to like write it out? Or
Yeah,
just
write out write out the steps that you're gonna take, and why that leads you to the minimum number.
Okay. So,
So-
that's the first step, is everything goes to 1.
Okay. What's the next step?
Next step is that's going to go to 2,
Okay.
because that's the only one that we can do without incrementing the wrong numbers.
Okay.
And that's going to go to 2,
Okay.
and that's going to go to 3,
Okay.
and then I got one too many. And that's going to go to 2, 3, 4.
Okay. Cool. So why did you pick this? And so why did you pick the operations that you did?
So I mean, I chose those operations based on the fact that like we can't increment the numbers in between our targets because
Mhm.
they're already at their required value.
Okay.
So maybe I'm not understanding what you mean by why did I choose this?
No, that's exactly why. Because you can't extend it any further because you've already this value is already at its target value, right? So you can't extend the range to the right or to the left. So, knowing all that, knowing what you need, knowing that limitation, does that help you come up with an algorithm?
Yeah, I thought, okay, I think maybe we had a misunderstanding earlier because I thought I was going that way, and then I don't know what happened, but something happened. Yeah, so I mean, like, basically we say what I was doing earlier, which is, or what if we, maybe that's an unnecessary step is storing all those indexes, because then we'd be looping like an extra time, I think. So if we did something like,
Well, keep in mind, in the algorithm you just told me, you didn't have to maintain an index array. How would an index array work here?
yeah, so actually what I was thinking now that I'm looking at this like written out is that maybe we can do something like 2 pointers, like 1 pointer at the start of the subarray that still needs to be incremented and 1 at the end, and we go until that reaches like the end of the list. But then how would you know what the numbers in between are is the question.
Okay.
So let's take like this step for example, or sorry, this step,
Okay.
and look down here. So we say, sorry, we'll need this step before it as well.
Sure.
And we'll just put zeros in here just to be safe.
Okay.
And then, so we'll say at this step, pointers are at 0. So
Okay.
we'll have like 2 pointers at 0.
Sure.
2 like that.
Mhm.
Or like, let's put it down here. So pointers are at 0. So we know that this number and everything in front of it needs to be incremented by 1. So that's what we do.
Okay.
So we can say pointers are at 0, increment everything from 0 to end of array.
Okay.
So that brings us to here,
Mhm.
where we can say we check the number at the pointer if it is equal to the value target increment both pointers.
Okay.
I'm not sure about incrementing both pointers and how that's going to work.
What?
out.
Yeah, because that's not what you did before, right? So.
Yeah. So the first step's easy, of course. This step is where it gets complicated. Is trying to figure out how we're gonna do this. So let's see. That needs to be. Okay. What needs to happen is 1 pointer needs to traverse through. No, because that's not. That'd be like O1 squared or something.
Why did you pick the end of the array?
Because we know everything in front of the pointer is not. So I mean, okay, we need to figure. I need to figure out how we know everything in front of the pointer is not yet at its target value.
Yeah, why did you pick it? Because end of the array seems pretty arbitrary. Because what if happens if I changed it to this? You know?
Yeah.
How did you pick the end of the array?
Okay, so pointer 1 is at 0. pointer 2 traverses forward until it finds a value at its target value.
Sure.
Okay, so in this example, we'd say that goes to there.
Okay. Now what do you want to do?
So now we want to increment everything from 0 to, or no, well, not 0, but pointer 1 to pointer 2 minus 1. So that'll increment these 4 numbers here.
Okay. Be a little bit
Sorry,
careful. What happens if I change the first number to 0? Does that change anything? Yeah, what happens if I change it to 0? Where does your pointer 1 then?
Yeah, so if the first number is 0, then what would happen at the first step is it would... Okay, so here, let me just write like a separate case up here
Sure.
really quick, just show what would happen.
Okay.
So we would have starting at 0.
Mm-hmm.
We would say, all right, traverse forward until you find a value at its target.
Mm-hmm.
Well, so we'd say like while pointer 2, while number at pointer 2 not equal to target or something like that.
Okay.
So it would just automatically trigger right away at the first number.
Okay.
So then, yeah, so what would we say? We'd have to do something like, if they're at the same number. Okay, so if pointer 1 is equal to pointer 2 and like target at pointer 1, so that's the value 0 is equal to the, what did we call it? We just called it the, we'll just call it the array.
Okay.
Then we just increment.
Why does this work? I want you, before you even write this, I want you to tell me what you're saying. Because right now I'm getting the impression that you're trying to write code and you're holding yourself back. Take your hands off the keyboard. Explain to me in plain English what exactly you want to do.
Okay, so if pointer 1 and pointer 2, so, okay, they're going to start at the same value.
Okay.
If that value doesn't need to be incremented, pop them up by 1.
Okay.
And then, so from there, assume, not assume, but like in the example, the next number has to be incremented. So then we'll take the bottom pointer staying at 2, or like the second value, and then the top pointer is continuing down the array until it finds a number it doesn't need to increment.
Okay, so you're saying this is our pointer 2?
Yeah.
Okay, so you're going to be looking for a number. So let me just do this just for the sake of. So you're going to be looking for a number that until you don't need to increment it. So it's going to land here. Now what?
Yeah. So, sorry. So the first step is we started at 0. That didn't need to be incremented. So the bottom pointer is now at the next position.
Okay.
And then that one would have started there as well. So they're both right there. Just so we're clear on where they're starting.
Sure. And then now you're moving it there. All right. What's the next step?
So now we can say everything between pointer 1 and pointer 2 minus 1 can be incremented.
Okay. Sure.
So
now what do you want? Okay, so now you're going to increment everything between that.
Yeah, so we're going to end up with 0, 1, 1, 1, 0, 0. Okay, so that's what we have now.
Sure. Now now you still have this tail end going on here, so
yeah, so there's no real way around that. That's just gonna have to get incremented 4 times on its own.
okay. But then suppose I extend out that array to be like 4, 2, 1, 5, whatever,
Yeah, so I mean, if we want to like look at that, then we can.
It's up to you. I'm just trying to help guide your thinking.
I think the case that we're working on right now will cover that
Okay.
scenario. So we'll visit really quick when we get to the end of this.
Sure.
and see
That's fine.
if we need to.
Okay.
So this is where we're at now. Pointer 1 is still over at that 0, and then pointer 2 is over that 0, and then pointer 1's down here.
Okay.
So, but now that we've finished that last step, we're going to check is pointer 1's value at its target value?
Okay.
No. But we're going to reset pointer 2 to be equal to pointer 1 again.
Okay.
And we're going to run it forward and then do that same thing. Run it forward until it finds the value already at its target value.
Okay.
So then at this point, it's going to be that next number.
Okay.
So we're going to do our increment to pointer 1 to pointer 2 minus 1. So that's just going to increment that number by 1.
Sure.
So, and then when we come in, we're going to say, or at the end of that, we're going to say pointer 2 is equal to pointer 1.
Mm-hmm. All right. Now what?
So now we say, is pointer 1 equal to its target value? Or the number at pointer 1 equals to its target value.
Okay.
And it is. So we increment it by 1.
Okay.
And this would be like in a while loop because we want to be like until it finds a value not at its target value.
Okay.
So because basically you don't want to do it once because then we'd run into the problem where, well, this number's already at its target value.
Okay.
So like within our function, we're going to be like starting out with a while loop until pointer 1 value not equal to target value.
Okay. Fine.
So this is already at its target value. We're going to increment again.
Okay. But you need to get your pointer 2 first, right?
No, so they're going to stay equal until we find a value not at its target value.
Okay. All right. Fine. All right. So now you found something that is not equal to its target value because you're aiming for that to be 3.
Yeah. So now we break out of that initial loop of incrementing until we find something not at its target value. And we go back into the next part of the algorithm that we've already discussed, which is increment pointer 2 until it finds a value already at its target value. So that goes to there. It's already at its target value. So we do our increment from pointer 1 to pointer 2 minus 1, and that's going to go to 2. Reset pointer 2 so it's equal to pointer 1.
Okay.
Here, I want to write out a couple of steps of like what I'm thinking, so that
Sure.
way when we reach the end of this, I don't forget what we've just gone over.
That's fine. Seems like
so-
you already have an idea of what you want to do, so go ahead.
Yeah, so while value at pointer 1 is equal to target value, increment both pointers by 1. So that's like the very first step of what we've got to do. And that's sort of what we've been going over. Okay, so we're at this value here, which is supposed to be 3, so we know it's not equal. So we increment pointer 2 again. So then I'm just going to keep adding on into like the pseudo code below while we talk about this. So we're going to increment pointer 2 until the value at pointer 2 is equal to its target value. So we're there. 0 is equal to its target value of 0. So we're going to increment the range from pointer 1 to pointer 2 minus 1. So if we come down another line, that's going to go to 3. So I'll just bring this down to the next page so we don't run out of room. All right, so increment the range from pointer 1 to pointer 2 minus 1, and then set pointer 2 equal pointer 1. So they're both at the same position. And then we come back up to the beginning. While value at pointer 1 not equal or equals target, sorry, while pointer 1 is not equal to target value. Hold on. What was I thinking here?
Okay.
While pointer 1. Yeah, sorry. While pointer 1 equal to target value, which it is, increment both pointers by 1. So boop, boop, boop.
Sure.
1, 2, 3. And then that's also, so we're still in this loop. Pointer 1 still equal to its target value. 1, 2, 3. 1, 2, 3. So we're at the last number. It's not equal to its target value, which in this case should be 4. So then we're going to increment pointer 2 until pointer 2 is not equal to its target value, or pointer 2 is greater than or equal to array dot length.
Mm-hmm.
Yep. So it is greater than or equal to array dot length, array dot length minus 1.
Mm-hmm.
Sorry. So it is greater than or equal to array dot length minus 1.
Mm-hmm.
So that doesn't go anywhere. Then we increment the range from pointer 1 to pointer 2 minus 1. So so that's not going to work when we're in this case of the last number.
Mm-hmm.
So we need to. What if we do? No. Sorry, I was thinking if there's like a way, because before we were like saying pointer 2 minus 1. I was trying to think if there's a way we can just like go from pointer 2 to, or from pointer 1 to pointer 2 without like the decrement. I guess it is if we check +1. So
Well, keep in mind that you are going to be checking with array -1. So it's okay if your pointer 2 runs out of bounds, right?
I guess as long as we handle that in the function that the range increment function, as long as we handle like one of the values being out of range.
Yeah, because again, at this point, the value of this pointer would just be array.length, right?
Yeah.
So then if you just take the range from that to array -1, then you should be fine.
Yeah, but the problem is it would be until it is array.length -1, so that would be 4, which it puts it here. But then we're incrementing from pointer 1 to pointer 2 -1, so it would be like from 4 to 3, which doesn't make any sense logically.
Right. So then what is your solution?
Yeah, so that's what I was trying to think about, was the because I mean the easiest way is just add like an if statement, like if pointer 2 is equal to like array.length -1, do it this way or do it that way. But I was trying to think if there was like a more clever way of just like,
I mean, you could just make your life simpler just by taking everything within the range of pointer 1 and pointer 2 and increment it. So, because I mean, it's all array length -1 anyway, right?
I'm not sure I follow what you're meaning.
Okay, so basically what you just told me, like, and for every single step up here, is that you're increasing the range between pointer 1 and pointer 2 -1, right?
Yep.
So then what happens if pointer 2 is equal to the array length?
Oh, it would just be 4. So we have 4 to 4.
Yeah, so then it would just it'd just be the same as if like you incremented just at that one point, right?
Yeah.
So where's the complication?
My head. That's where it is.
Exactly. Write this shit out.
Yeah, so then increment pointer 2 until value pointer 2, or pointer 2 is greater than array.length -1. So we'll just change that to greater than, not greater than, equal to. Yeah, because then that'll put it up. Okay. Then increment the range from pointer 1 to pointer 2 -1, so that's over there, and that's that. So it increments 4, and then set pointer 2 back to pointer 1, and then that's going to go from 1 to 4 on that last slot.
Mm-hmm.
But if we talk about the example you gave before, where like the target had like 4, 2, 1 at the end,
Mhm.
well then it would just keep going the way it has been working before. Or sorry, that would be 0, 0. It would just keep going the way it was working before and take like that range. So
Sure.
I think that's fine.
Okay. So now you have your algorithm, right?
Yeah. So we have a basic pseudocode algorithm right here.
Okay. So why don't you write it out and we'll discuss. Like write out the actual implementation.
Okay, I'm gonna move it down so I can look at it while I write. So we'll do function. Something like that, and then we'll take in the 0 array and the target array. And then, okay, so step 1, pointer 1 is equal to 0, pointer 2 equal to 0. Get those to the start of the array. And then we can say while pointer 1 was our exit condition? Yeah, while pointer 1 is less than array dot length, or sorry, I guess it would be like 0 array dot length. Doesn't matter which. It doesn't matter because these two are always equal lengths, right?
Yeah.
Okay, so it doesn't matter what you use. Okay, so, and then basically all that's going to do is like, if we look back up at the example, once that last number hits its value, it's going to increment pointer 1 again, and then it's out, so then we'll exit out of the loop. So that should be fine. Yeah, so then we need another while loop here. While the 0 array at pointer 1 is equal to target array at pointer 1. We want to increment both pointers, so that's just going to be pointer 1 plus plus. I'm just gonna, because the spacing's weird, I'm just gonna save some space and not write in.
Sure. I honestly don't care. I honestly don't care that much.
And then we come in and we say increment pointer 2 until the value of pointer 2 is equal to its target value. So basically, we do another while loop here. This is already going to be horrible runtime once I figured out what it is.
Whatever. Yeah. At least you have an answer though.
While 0 array dot pointer 2 is not equal to target array pointer 2. Yep, so that'll keep incrementing until it is equal. Then we will do pointer 2 plus plus. Oh, and we can't forget our OR statement, or pointer 2 is greater than target array. Let's be consistent. We use 0 array dot length earlier.
Sure.
-1. And then we increment the range from pointer 1 to pointer 2 -1. So what was the name of the function? It was range increment. Did you want me to write the range increment function, or are we
No,
just assuming
just
that's,
assume it comes to you.
that's something I should have asked earlier, probably.
It's fine. Okay.
Pointer 2 -1. And then we set pointer 2 equal to pointer 1. So let me say pointer 2 is equal to pointer 1. Yeah, so let's run this through at least some of the test case that we came up with really quick and see how it works. So let's target there. So we have 0, 0, 0, 0, 0, 0.
Mm-hmm.
And then we have pointer 2, pointer 1.
Mhm.
So pointer 2 is 0, pointer 1 is 0, yep. While pointer 1 is less than 0 array dot length,
Mm-hmm.
it is. So while 0 array pointer 1 is equal to, and it is. So
Mhm.
don't do anything there.
Mm-hmm.
Or sorry, we do something there. We increment it by 1.
Mm-hmm.
Both of them by 1. That is no longer true, so we break out of that. And now we do while 0 array pointer 2 is not equal to target array pointer 2, so we increment that forward by 1. Still not equal, increment it again, still not equal, increment again, is equal, we break out of that.
Mm-hmm.
And then we range increment from pointer 1 here
Mhm.
to pointer 2 minus 1, so right there.
Mhm.
And then set pointer 2 back to pointer 1.
Mhm.
And then, so we come back up, 0 array pointer 1 is equal to blah blah blah, and we go, sorry, we don't need to increment there. I shouldn't have blah 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 that, but basically this number is not equal to its target, so we don't move pointer 1 or pointer 2 off of it.
Okay. So
we increment pointer 2 now. We find the next value is equal to its target, so we don't increment it anymore, and then we increment right there, and then we do it again. And now we're basically doing the same thing as we did earlier, so I think this is pretty equal to what we wrote earlier.
Okay. So I'm going to give you a quick pause. I want to point out one thing.
Yeah.
What do you think I'm going to say?
Oh, I wish I knew. I
Okay,
think you're gonna say,
look back at how you progressed through the problem and just imagine what I would say. Given like our discussion about, planning things, to avoid writing code, all this stuff, what do you think I am going to tell you?
write examples, because as soon as we started writing out the example, it made more sense to me and probably to you.
Holy
That's what I was
fuck, you
thinking.
figured it out. Yeah, you didn't need to like sit 40 minutes doing like some random problem. You already knew the answer. Draw this shit out, man.
Yep. I should have remembered all the videos I watched of you with other people instead of yelling at them to draw it out.
Holy shit, you don't need me here. You already know the answer. Like what the fuck is this shit up here? Like increment, like call range increment. Like, well, you don't know what your algorithm is to begin with. And I literally had to tell you, okay, just try it out. What's your basic example look like, right? And then like, okay, what happens if I change these parameters? I was like, oh, okay, well, this changes. And then it's like, okay, well, now you have your 2 pointer examples. And then you actually went through it step by step and you're able to derive an algorithm. Wow. It's almost like if I took the very basic steps and just followed them, I'm going to find a pattern that I can write code with.
Yep.
Like, shocker, right? Super shocking.
Yep. You think I would have learned from all your other videos?
I think like literally every single video that I've done in the past, like, I think like 5-6 videos, is like, just draw this shit out. There's no reason to throw some random crazy ass pattern on this problem. Like, it's obviously like there's no obvious pattern that comes to you. Like for the very first one, it was obviously a tree, so you could do a DFS and in order traversal. But this one, there's no obvious answer. So what do you need to do? You need to break it down from the ground up. Look for patterns. And you already started with the 2 pointers. It's like, okay, that's really cool. And you just started to go through it step by step, see what it took to transform it naively, and the fact that you were able to explain it without having to write any kind of like code or any of this like pointer 1 equals pointer 2 crap. The moment I told you to stop writing it, you actually focused on just traversing through the problem and actually trying to understand it. It's almost like writing code at the very beginning is distracting you from actually understanding the problem.
Yep.
Because code is the execution of an idea. It's not the idea itself. You need to focus on having the idea itself in order to be able to even make it through the problem. And what you're doing is the exact opposite. You're executing on a non-idea. And that's what's been holding you up, I think, for the first problem, the second problem, and now this one. So, like, you already know the answer, like, I was going to give you. Now, of course, this is not optimal. There's obviously things that you can do, but at least you have an answer.
Yeah, because this is gonna be like I don't know what it is off the top of my head. It's at least O(n) squared, if not worse.
Let's see. Let me run through it. Okay, so pointer n, n and then for each AND operation, you're doing an order n. Wait, I have to think about this one.
'Cause,
Either
like,
way,
is
it's
it-
like giga unoptimal. It could be like n to the it's power. I think it's power because each time you're doing it, you're running through n possible times. So like for instance, you're gonna be iterating through the zero length array, which is an order n operation. And then for each time you have that, while you have a zero array equals the target array, you're gonna do an n operation as well. So these two whiles determine the n. So it could be n to n, I think. Like I could be wrong, but essentially you have a very crappy runtime.
Yeah, I don't know what the answer is for the better runtime.
Okay, but there is a way to figure that out. In fact, let's talk a little bit about optimizations. And so, looking at what you've written and the example that you've worked through, what do you notice? Is there anything special about any particular characteristic of the problem that you notice?
We got a lot of while loops.
Okay, yes, we got a lot of while loops. Anything else?
Both while loops are incrementing pointer 2.
Okay, both of them are input point true. Yes, that there's a lot of redundant work here, because you're doing nested while loops and you have 2 pointers, and you have a pointer that's constantly being incremented. How do you get rid of this? You understand what a target? How do you get rid of it?
We could probably do it with 1 pointer, but all that would really do is simulate pointer 2 with a single pointer.
Okay.
Because then what I'm thinking is like let's pretend we just have pointer 1 and it's starting at a value,
Okay.
and then you would just like save that index and then start incrementing it until you find the number that's already at its value. And then you would just take that saved index to pointer 1 minus 1's index and do that.
Mhm.
And then you'd reset it back to the saved index that you had at the beginning.
Well,
But-
keep in mind you also have another bug in here, and I'm not gonna harp on it too much, but I want to try getting you into this mode while we still have time.
Okay. Yeah, so that's like my immediate thought is get rid of pointer 2 doing that. It doesn't affect the runtime, but it cleans up the code a little bit, I guess, probably. So yeah, that's my...
Okay. I do want to say, so let me actually make this a little bit more clear to you. What happens if I change this 1 to a 6? How does your answer change?
Let's see, so I'd get like... 2, 0, 0. So to get to that point,
Okay. Now what?
let's just assume a 2-pointer method still for now. Those are both get incremented to the next number. We're going to look at this because you highlighted it.
Mm-hmm.
While 0 array, so let me back these up. We'll start this one from the beginning. So we'll pointer 0 array pointer 1 is equal to target array pointer 1, which it is. Increment both there, break out of there. 0 array pointer 2 is not equal to target array pointer 2.
Mm-hmm.
So 0 array pointer 2 is 2. It is not equal to pointer array.
Mm-hmm. What do you notice about that condition?
I'm kind of actually looking more over at this condition, but
What do you notice about like what you don't worry about the code right now. What do you notice about where your pointers are and the state of the array?
target array pointer 2 not equal to target array pointer 2. 0 array pointer 2 2 is not equal to 6. Or I'm not picking up what you're putting down.
This 6. You're only here because the numbers on both sides of this are less than the peak. Does this ring any bells?
Or less than the peak.
Mm-hmm.
So I mean, but that would just get incremented to there, and that would it would go 2 6. It would go 2 3 3, and then that would get reset, and then that would get incremented up to 6,
Mm-hmm.
and then they would both go up.
So which means that for that chunk of array, how many operations do you need?
6.
Mm-hmm. Does that help you in any way?
So the peak is always going to need the most number of operations. So if we started at the peak and worked out from there rather than the start, is that where we're going with this?
Mm. Okay. It's gonna be a little bit more complicated than that, but you know, the last 10 minutes, I'm gonna just give it to you. So the first thing is what you did. Like, I wouldn't have thought of it this way. I would have thought of it as a binary search. Like, so for instance, let's take the example I just gave you, right?
Mm-hmm.
So 026300. I'm gonna start at 0 0 0 3 4 5 6, right? And so here, I'm looking at this and thinking, oh well, I know I need to just chunk this range and increment it by 1, right? Right?
Yeah.
And then I can just consider that a subarray. And then just do my operations on there again. Because isn't like a subarray of an array is just still an array, right?
Yep.
So then after that, I can just look at, okay, well then I only have to look at 1 1 1 1, and then just increment it 2 2 2, and then and then 6, and then what's it called? Chunk the array again into 6 into 3 3. You get the idea. This is basically where I would go with it, and I would model it after binary search. And then my runtime becomes n log n. You see where I'm going with this?
No, because doesn't binary search need a sorted array?
I mean, yeah, but that's the nature of a binary search. But I'm saying I modeled it like a binary search, where I am like for every operation, I'm taking for every array, I'm dividing it.
Okay.
So sorry, like a sorting algorithm, like a merge sort sort of thing.
Yeah. So you're looking at it more like a sliding window almost kind of.
No.
Okay.
Disabuse yourself of the notion of a pattern right now. I'm looking at it and sliding window, yes, but more of a sorting algorithm where like divide and conquer. Ring a bell?
Right. Yeah. Yes. And it rings a bell, but I don't have like the answer in my head.
Either way, think of it this way. It's like for each chunk I take, then I'm going to take a smaller chunk and a smaller chunk and a smaller chunk of it. Right?
Yep.
And basically I would just do this recursively. I wouldn't try to do it with like your crazy number of pointers and just increment it, because I know for sure that each time I recurse, my array is going to be smaller than the previous one. So I know my bounds are going to be limited, and they're just going to increment inwards until I have nothing left. So I don't need to do like this crazy start from the beginning and run all the way to the end. Right?
Yeah. So basically, you would take that subarray of 3 numbers and increment it until one of those numbers reaches its target, and then you would recurse down the whatever targets or whatever numbers are not met.
Yeah, essentially that. So this is where we get to the idea of peaks. And then this becomes 4, 5, 6. You get the idea, right? And so when I'm going to look at this, I'm thinking, well, the limiting factor to all of this is this peak. So what I'm going to do is I'm going to look through it n here, and then just like grab all the numbers that need to be incremented up until the number starts dropping off, because it's either going to be because at that point, then it's going to be kind of a weird situation, right? So I can extend 2 6 3 all the way through, right?
Yep.
So I know I'm going to need 2 operations in order to fill this all up.
Yep.
And
So
then
you need basically the minimum number is the number of operations.
correct. So I just go until I see let's say I pick 0. If I see a larger number next to it, I'm going to pick my pointer here. Let's say a V. And then I'm going to, now this is my pointers right here, right? It's very similar to what your 2-pointer situation is, where I'm going to look until I find a number smaller than the pointer 2, right? Now, that leads me to 0 here. So I know that I need to increment everything in between. So now, and I know that the number of operations that I need to do for this is going to be 2.
Yeah, okay, so then instead of doing what I did where like I would increment it and then reset everything and look again, basically you're doing it recursively so that way you kind of never lose
No,
that.
not even recursively. I'm saying that this is the more optimal way. The binary search was, not the binary search, but the divide and conquer was just an example I want to give you of where I would start. Why? Because because the moment I did the divisions, like, where I marked the divisions is going to be where I mark these pointers, which leads into what you did. Does that make sense?
So
Let me show you the answer because I get the feeling you're gonna need to see it. Then it'll make sense to you.
Okay.
So now like I filled this up, right? I'm gonna look at 6. 6 here. It's like, okay, well I know that I need to fill this up 6 times in order for me to get past this, because again, same thing, same issue that I had before. I have this wall here. I can't get past it, so I know that I'm going to need an additional at least six operations, because I don't care what's here. This could be 3, 4, 5, 6. Same situation, right? Let's put it back to 3. So I know I need 6 operations to fill this up, and then I'm going to look for something higher. Because at this point, right now, it's been fine because everything has been incrementing up until now. So what happens when it decreases, right? Well, I know from this that because I've had to fill up 6, that I can also fill up 3 on the side while I'm filling up 6. All I have to do is just increment, my range increment just needs to increase by 1 bound. Does that make sense?
Yep.
So now I know, okay, well, 3 doesn't matter anymore. So I'm going to, now my pointers meet up here at 0, right? Yep. Now we go back to the starting case where we had the very beginning, where it's like, it meets its target. Rinse and repeat. So the only thing I changed here was not starting at the very beginning. All I did was really say, hey, if I'm incrementing, if my target, if the next number is larger, then I am bound by that number, and I'm going to count the number of operations that I need. That's it.
Yeah, so you go... So basically you start at...
I mean, this helps. If this helps you.
I guess where I'm being lost is you already would have had 2 operations from the 2, but you were still saying you needed 6 on the 6. But
I needed
already
4
had
more.
2.
I need 4 more. Sorry, I misspoke.
Oh, okay, that's
Yeah.
where I was getting confused.
My bad. Yeah. So it's basically, that's the basics of the algorithm. I'll let you figure out the implementation. But essentially, all I did here is notice that what I did. I just explained to you what I was doing. I didn't write a single line of code. I just drew it out, and you understood the idea. This is where I want you to get to at like the next time I see you. I want you to be able to explain an idea without having to write a single line of code. Because let's look at all the problems that we did today. We did the first one where it's like you got the answer, fine, but you made all these little hiccups. And, of course, probably when you're practicing, you're thinking like, it's just a small careless mistake, nothing I can do. Well, usually when you see these careless mistakes happen, there is a root underlying cause. And right now, my job is to show you what that root underlying cause is, so that way you don't make those careless mistakes again. Because these can really ruin you depending on where they come from. In this case, I showed you that you made a lot of like little small mistakes and shows here, and that led you to missing this answer.popup because, like you admit, you were doing this in your head. So,
Yeah.
And then there's like also a bunch of other small tells that other people can pick up. So if you had done this all on your own and you were like practicing in a room, you probably wouldn't have noticed this. So this also came through in the second problem, where you started realizing, hey, wait a minute, I maybe shouldn't be drawing code. You at least got that intuition. Now, of course, you need to work on graphs and understanding what the hell is going on with them, topological sort, Dijkstra's algorithm, all that good stuff. But at the very least, you took the time to actually understand what the problem was telling you. I was fine with that. I was fine with the way you handled it, even if you didn't know how to do the problem. This hard problem, you wasted a shit ton of time just like randomly trying random problems. And then all it took was you drawing it out, very simply what your idea was without touching code, like I just did, and you were able to figure out what the answer was. You were able to come up with a very basic algorithm that works. Granted, it's not optimal, but there's a pathway between your suboptimal solution and an optimal one. All you had to do was just recognize peaks and valleys.
Yeah, so I guess assuming like so the next step from that is kind of like just recognizing a better pattern, basically. I recognize that pattern, but I need to recognize a better pattern.
Yes and no. It's like if you had kind of paid attention to where and why you're resetting this pointer to, and what's the better way of placing it, or if you thought about how can I avoid resetting my pointer, then I think the answer would have started coming to you.
Yeah, maybe. I think part of the problem in like interview settings that I have is like I feel the need to like not stop talking to think, but it's really hard to think and talk for me at the same time.
I don't care how much you talk. That's the thing. Like, in fact, if you think about it, all I said was, hey, communicate to me like you are a 5-year-old child. Like I'm a 5-year-old child. And notice that what I did, I just drew a bunch of numbers, typed it out, and kind of explained what I was thinking and said, oh yeah, this. You know, I like, and I don't necessarily need to keep talking. Sometimes I can just like I can just say, hey, let me just draw this out or some shit on the Google Doc. That would have been perfectly fine. At least the interviewer knows you're kind of churning through it, and then he might ping you, hey, so what are you thinking? Da 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 da. But again, your problem isn't like over communicating or under communicating. It's what you're communicating. And right now, the way I see it is that you're focused on using code to communicate, when it really should just be you trying to get the underlying idea first, and then using code to express it. And the first step to that is being able to draw out and explain your idea without having to write a single line of code. So this is what I want. This is your homework. So let me write it out. 1. When you do your problems, draw out the ideas before you write a single line of code. So look back at what we did. Look back at the session as well when the live stream ends. Rewatch it to your pleasure. And try to like look at your own performance and see and going into it with everything we discussed. I want you to see your own mistakes. Like it has to stick out in your mind. So rewatch this. The second one is that be able to explain things simply without using code. Because the problem I saw was that, oh, well, I'm going to use a DFS and I'm going to do this. Well, again, the first thing is that if you immediately jump to technical things, then I automatically assume that you know what the heck you're talking about. And then, you know, when you say, oh, I'm going to do DFS on a binary search tree, and I'm like, well, in-order, pre-order traversal, you know. So don't jump into technical shit. Build up the argument and logic, starting from the drawings. And the third homework I want you to do is really to start to be patient with yourself. Because I think the reason why you fell into this habit was because you're trying to beat a time. You're trying to like, oh, get faster. The speed will come, but really you need to focus on getting the fundamentals right. Because it doesn't matter how fast or slow you really you do. Like to an extent it does, because speed is just a property of competency, not the other way around. Just because you're fast doesn't mean you're right. But if you're right and very proficient, then chances are you're probably going to be fast. So I want you to be really patient with yourself. I know you don't have a lot of time, but if you could at least get this, the basics right, then I still think then even if you don't know anything else, then you're going to have a pretty good chance of getting Google. Does that make sense?
Yeah.
Any thoughts on anything that we've talked about today? Any questions?
I guess my thought is at least I knew what my problem was going to be going into it.
Mm-hmm. So you know your problem and you know what to look out for. I've given you the remedy. All that's really left is for you to execute on this.
Yep. So yeah, I'm definitely gonna probably try implementing your solution to this last problem.
Mm-hmm.
See if I can figure out exactly how that works, and then from there, just like I got to keep learning those last few things like graphs and whatnot, because those are definitely important to know.
Mm-hmm.
And from there, just practice drawing it out.
Mm-hmm. Yeah, so when you do your graph problems, your heap problems, I think this is actually a good candidate for you to actually, so that you can fully understand them. draw that shit out. Draw what happens when you use a heap. Draw what happens in each one of the problems. And it's a great way to learn about how they work as well. So why not just combine the two? Because at least, it might take you a little bit longer, but at least you'll do it right and you won't be confused.
Right. Yeah. I should just I should get a pen and paper and not try to do this like all on the pages or on the screen as much.
Yeah, you start like when I was doing these problems myself and I was studying for interviews, I always did pencil paper. I never really submitted code to LeetCode. I would just only write the LeetCode at the end and then just compare my answer. And if I made a stupid mistake, I'm like, okay, well, what happens? Why did I make the stupid mistake? It's because my page was unorganized. And I think I have like a few videos of me actually doing problems where I fuck up. But it's not because I don't understand the problem or I can't get it right. It's because, I had the right idea and I just because of this one little stupid step that I made, like not keeping my page clean, that translated wrong to the code.
Right.
So it's not like a fundamental misunderstanding or not knowing how to get the answer. It's literally, oh shit, because I had to transfer from this step to this step, some small unrelated code shit. So.
Right. Yeah.
So, you have plenty to chew on. I'm gonna let you go. Good luck, man, and let me know how things go.
Appreciate it. See ya.
All right, for sure. Take care, man. Oh. Right. Our minimum span. Okay, so yeah. Hi guys. So that session actually went pretty well, actually, surprisingly. I felt that he actually did a pretty good job of understanding what I was doing, and I think the moment he started realizing he shouldn't be writing code, I think that was like the biggest breakthrough I think I had with him. I think that for the most part, if I can get any clients to that point where they start realizing their own mistakes, then they can at least start executing on how to, get over that. So for me, I felt I did a pretty good job of doing that. I really want to see how he progresses. And I'm very curious because there is some knowledge gaps for sure, especially when it comes to heaps and dynamic programming and graphs. But for the most part, I really think that it's going to boil down to how much of this he's really able to snap up in like a week or two. Hopefully he has enough time, and hopefully he gets it. So let's go down to questions. People turn off autocorrect, auto-capitalization, and auto-suggestion on Google Docs when doing a coding interview. It's easy to do, and it won't annoy you during interviews. Yeah, that's a pretty good suggestion, actually. Are minimum spanning trees fair game in these interviews? I would say that it is fair game, but it's not likely to be asked. I don't remember it ever being asked to me, and I don't know anyone who's ever asked minimum spanning trees, but I would not put it past someone. In fact, like graph problems are kind of falling out of favor just because they get kind of complicated, but minimum spanning trees are still there. So, all right. With that, I guess I'll wait for another few minutes before ending the stream. If anyone has any other questions, now's the time to ask. Also put some Dota on while we're waiting. Oh shit! Wait! I just came into a game. GG. The heck? All right, man. All right. Okay, well, I guess we have to look for another channel, and that hopefully they don't have like something that's instant GG as well. These PGLs, ever since the major ended, these games have been really, really good. This new patch has been like pretty wild. PL's like busted as shit though. Wait, hold up.
I mean, the Morphling just did so much that game, we flagged it.
What's your favorite ice cream? Whoa. 1v1 me IRL. My favorite ice cream is like, I would say strawberry cheesecake. That shit's pretty good. Like, I don't know, I like the really sweet stuff that's really tangy as well. My mid SF is god tier.
It felt like the item
I
wasn't
don't
applied
I don't play
to
SF mid actually. I played like TA mid, Storm the Spirits mid, and then a lot of farming heroes. Holy shit, like a ridiculous amount of farming heroes. Actually, I might as well just be playing carry at that point, to be honest. Are Dota games still plagued by toxic people rage quitting? Not as much, actually. I think they did a really good job of cleaning up the community, and I haven't really had a rage quitter in like 4 or 5 years. Then again, I have like 10,000 behavior scores, so I've never actually seen that myself. But how frequent do people get dynamic programming questions? I think one time every interview, I would say, like, and when I say interview, I mean like with a company. So, for instance, if I have 5 rounds with Google, I'm going to get at least one dynamic programming question for sure. What was your first childhood pet's name? JK, my question. No. Yeah. But yeah, I think dynamic programming is one of those things where you have to really understand like what bottom-up memoization is, and how trees work. And that's why I don't really cover it that much. It's because for most people who come to me as clients, the most value that they're going to get is by fixing their execution on any problem agnostically. Because I feel like if you can set up yourself to properly do a dynamic programming problem, then you're not going to have any problems actually doing it. But if you don't know how to set yourself up for any problem, then you don't know how to set yourself up for dynamic programming, and you're not going to understand what dynamic programming is at all. Like, so without going too deep into dynamic programming, so for instance, let's say we take the coin change problem, right? And so, you know, the number of coins it's going to take of certain denominations in order to get a particular value. So I can either optimize against either taking like, you know, a certain number of coins, coin A, coin B, and coin C, right? Or I can take the target value minus the value of coin D, minus the value of coin D plus A, B, C combination. Or I can do what's called A, B, C, D combination. One of those two is going to be like the maximum number of coins that I can use, or, you know, or the number of ways I can get there. I can just combine those two values. But as long as I have those two dimensions and I understand where I am going with it, then that's fine, you know? So that's what I mean by setting up the problem. Is that you have to understand what you're optimizing against and what dimensions that you're going to be using. And if you can't really understand and break down a problem at that fundamental level, then there's no reason that I should be able to try and teach you what dynamic programming is. That's why I always save it for last, and I very rarely teach it. Although I think that maybe I'll put up a video on that. But for the most part, I think that focusing on the execution of any problem, any agnostic problem, is going to be the correct way to go. I got asked one for a Fang phone interview. Holy shit, dude! You got asked a dynamic programming question for a phone screen. Was this Apple? Like, I would not put it back. I would not put it past them. Like, there are some teams in Apple that are super hardcore and will ask you how the OSI model works, even if you're a backend developer. I'm like, holy shit. Let's see. Ooh. Google. Yep, I kind of figured. I mean, that's also another one. That's kind of fair for them, but you know, what are you gonna do? Oh, Tulio online assessment, really? Yikes. My condolences, man.
Gunner in some trouble here. Jumping gets freeform off, but
this is Zoomers.
Can they get out of there in time? The golem comes out, connects on to everybody. Look at the fatal bonds afterwards. Is it going to be enough though? The avalanche, the cost, fear is down low. Gunner, he's gonna fall. Man's living on nothing.
Holy shit, they got wiped. Holy fuck.
And then the heal from the bear and right-clicking him. Holy crap.
Is the bar lower for internships? Well, not really. I would say that if you can solve a medium leak code problem, you're fine. But I would say we still kind of judge it to pretty similar standards. Not much. It's like not that much lower that it's worth mentioning. I would say just train for your internships the same way you would for an actual interview. No point. There's no point trying to there's no point trying to game the system. Just do the best you can with everything you got.
I don't know, that looked like such a big mess. Like, the Fatal Bonds was so good, but all I saw was...
Death Prophet's still a hero?
A lot of spells, and
didn't she get nerfed to the ground?
Low in the zoomers, and suddenly they all just kind of came out alive.
Oh, Monster's playing. Nice.
Well, and
Yeah, I met this. Actually, I met Monster back when he was still in San Jose. I think he went to like UC, like a UC Riverside, I think. And then yeah, like I remember him, Kenny, and a bunch of other people. I think Monster went to what's it called, Australia for a little while. But yeah, he's a pretty chill guy actually.
Now, of course, figure out a game plan for Penta Ace.
Yeah.
Big item on Fear would be really nice. If they could just like finish.
All right.
with,
If there's no more questions, I'm gonna stop the stream. Thank you everyone for attending. Hopefully I answered all you guys' questions, and I will let you guys know when I do another one. All right. Take care, man.
He thought people were looking in the trees, I think.
Yeah. Damn, dude. The tips in this game are